Okay, let's try using this again. So now here's another math question, and then once again we'll try to give some meaning to it. So this one's worded a little bit differently. Find t if f of t equals 20. So again, the question is, what's 20? Is that 20 years again? Should I put, am I being asked to take 20 and dump it in like I did for the 16? Well, look carefully. The answer to that is no. There's a couple ways I can tell. The first is the first two words here say find t. I don't know what t is, obviously. I'm supposed to find it. The other thing is look at the 20. It's not in the parentheses. It's coming out. It's on the other side of the equal sign, which means this 20 isn't a t, it's an n. Remember, f of t is interchangeable with n. So you're being asked to put the 20 where the n goes. In other words, where the f of t goes. Where is that? It's right here. So go back up to the left side of the equation and replace f of t, or n, with 20. You're not putting something in. You know what came out, and you're going to solve to figure out what went in. Notice this problem requires a little bit of algebra because I have to get this t by itself. I don't know what t is right now, and so I want to get it by itself. So a couple of algebra moves. Looks like subtract that 137.2 from both sides. That's going to give me negative 117.2 equals negative 5.9t. And then I'll have to divide both sides by that negative 5.9. And so let's grab the calculator and do that. And I'm getting about 19.8 for t, typing that into the calculator. So I'm finished with the math, right? I was asked find t if the f of t was 20. We put 20 for the f of t, we did our math, and we got a t value of 19.8. Now the next question goes on to say, well, again, what does that mean? What information have we just found? It's all about realizing which number stands for which item. Remember, at the very beginning we decided this 20 is not a t, it's an n. So what's this 20 right here? It's 20 billion letters. We were figuring out, hey, when is the post office going to be down to 20 billion letters being delivered? And we did the math, and we ended up with a value of t. What's the t? What's the 19.8? Well, t, we know, is measured in years. To be specific, years since the year 2000. Now, when we've been doing years, we have not been worrying about decimal points and months and days and all that. We've just been rounding to the closest year. 19.8, the closest year, that would be approximately 20. So our sentence would be, in 2020, this is tricky because both numbers are kind of 20. This 20 came from here. In 2020, the post office delivered 20 billion letters. Again, this 20 came from up here, the 20 in the original problem. Is this a true statement? Again, I have no idea. We're just saying that if those trends in that table continued, this would be the prediction that by 2020, the deliveries would be down to 20 billion letters. So we're using our model to answer questions, to make predictions. Let's go on now and talk about the actual numbers that are in the equation. So we had a couple of numbers in the equation. Let me write the equation down here so we can take a look at it. So let's take a look here. Notice what it says in the directions for part I. The slope, when you're dealing with a linear model, can also be called the average rate of change. So those two words are used interchangeably. Obviously, our slope in our problem was this negative 5.9. Now there's three things you can talk about. You can talk about the value of the slope. That just means the number. So our slope value was negative 5.9. Then you can talk about the units of the slope. Units are things like feet, pound, days, letters, that kind of stuff. Slope units are a little bit tricky because think about how the slope is calculated. It's calculated as a fraction, right? We actually calculated that in a previous part by doing the second y minus the first y, the second x over the first x. If you look back at that calculation, the numbers on the top were output values. In other words, they were billions of letters. And the numbers on the bottom, I think it was a 10 and a 7, those were years. Well, the slope units are always the y units of the problem, then the little word per to stand for the fraction bar, and then the x unit singular. And so the answer here to this little part, what is that negative 5.9? It's negative 5.9 billion letters per year. You say, what is that trying to say? What is the meaning of that? Well, that's what we'll do in this next part. When you want to give the meaning of the slope, you generally use either the word increasing or decreasing, and then the slope is essentially telling you the rate, that's why it's called the average rate of change, the rate at which the situation is changing. So in our particular problem, we would say something like, the mail delivered by the post office has been decreasing. Now, how do we know decreasing? Well, obviously because of the negative sign. I mean, we knew it was decreasing just from looking at the data in the table, but we've also learned that when the slope is negative, the line is decreasing. So the mail delivered by the post office has been decreasing, and then you can say by, and then simply put in the value and units of the slope. You don't need to include the negative. That's already covered by the word decreasing. So you'd say it's been decreasing by 5.9 billion letters per year. This is the sort of thing that would be reported in the news, right? Oh, what's going on with the post office? Well, you know, they keep delivering less mail. In fact, it's been going down by about 5.9 billion letters every year. That's a summary of what we discovered through this analysis. So the slope has a very real meaning to the situation. I can't emphasize enough this part right here because that's really the key, I think, to understanding it. Take your y units, the little word per, your x units singular, and that will help you to think through the meaning of the slope. What about the other number in the equation? What about the 137.2? Well, that's letter J. Take the n-intercept of the model and write it as an ordered pair. And I don't know about you, when I read n-intercept, I just go, well, which one is that? You know, is that the x-intercept or the y-intercept? I might have to go back to the let statement. N is what's mentioned first in my let statement, so I know that's the y value. I know that's the dependent value. So they're basically just asking me what's the y-intercept. I don't have to do any work for that. Here it is right here. We've had the y-intercept for a long time. To make it as an ordered pair, I would just have to put a 0 in the x position, or I guess you would say in the t position in this problem. And so there it is. And then part K says, well, so what does that mean? You know, does that have some kind of real life meaning? And the answer is yes. This is not a complicated one like the slope. Only the slope has this per thing and the increasing, decreasing. This is going to be a simple sentence, just like the earlier simple sentences that we wrote. You just have to connect the units to the values. This is t, this is n every time, right? The first number is always a t, the second number is an n, which means this is years since 2000, and this is billions of letters. So what are we saying? Let's see. In the year, well, what year would we be talking about? If it's 0 years since the year 2000, then we're talking about the year 2000. In the year 2000, the post office delivered 137.2 billion letters. The y-intercept, or in this case the n-intercept, always turns out to be some sort of starting value. Our starting year in this problem was the year 2000. And so the y-intercept, the n-intercept, is telling us, well, here's what happened back then, according to our model. So back then, they were delivering 137.2 billion. True, I have no idea. That would simply be the case according to the pattern we have from our linear model. Okay, let's wrap up the post office problem with one last task. What about the other intercept? And there's generally two intercepts, right? An x-intercept and a y-intercept. We found the y-intercept. What about the x-intercept? Or, of course, for us, it would be called the t-intercept. T is our x in this problem. Well, that number is not in the equation, right? Let's take a look at the equation again. I've only got two numbers in the equation, the slope and the y-intercept. I don't have the x-intercept, or otherwise known as the t-intercept. So I'm going to have to find it. Well, we know how to do that. We learned how to do that back in chapter 1. If you want to find an intercept, you set the other variable to 0. Well, so if I want the t-intercept, I'll have to set n to 0. Where's n? It's right here. N is f of t. So set the n, or the f of t, equal to 0, and then solve. And so once again, I have a little bit of algebra to do. I think I'll move the 5.9 t to the other side by adding it to both sides. And then I will again have to divide on my calculator and see what I get. And when I divide, I am getting t is about 23.3. The directions say to state the answer as an ordered pair. Let's see, the t value, which comes first, would be 23.3, and I know it's an intercept, so I know the other coordinate is going to be 0. That's how we started this problem. We filled in a 0 for the n. So here are the coordinates of the t-intercept of the model. That was all math. What about the meaning? What is this ordered pair telling us? Well, remember, and I think it could be helpful in these problems to just write a little t first and a little n second. It just reminds you what these numbers mean. Every time you have a number in this first position, it's always the years, according to the let statement. And every time you have a number in the in position, it's always the billion letters. So we've been rounding our years off to the nearest whole year. That would be 23. 23 years since 2000 would be the year 2023. So in 2023, what's going to happen? Well, we're saying the post office is not going to deliver any letters. In other words, I think we're saying the post office is going out of business in the year 2023. Now, is that going to happen? It seems doubtful, right? The whole point of these kind of studies is people who care about the post office, people who work higher up in the post office, they're going to look at these trends and they're going to go, hey, we better do something. We better find some new way to stay in business and change what we're doing, or else we're going to run out of mail to deliver if these trends continue, is the idea. Okay? In any case, you can see, though, I think when you do this, the value of using math to describe situations so that you can analyze and make predictions and gain a greater understanding.